Hello, I'm ETarte, math teacher. This is a solution video for my math challenge, Triangle and Squares. In that challenge we have an equilateral triangle, meaning all three sides are the same length. Each side is length S, and inscribed in it are these two squares, each with side length N. And I had two questions. First question, what does S equal in terms of N? Second question, what is the ratio of the total area of those two squares to the total area of the triangle? Well, a fact of geometry that is important in the solution is the side relationships in a 30-60 right triangle, as shown here. The short leg, that's the leg opposite the 30-degree angle, with length A, then the hypotenuse is twice that long, length 2A, and the longer leg has length A times the square root of 3. Each angle of an equilateral triangle has measure 60 degrees, so we can focus on this 30-60 right triangle. This length from here to here is S over 2, and this length is N. And therefore, this length, the shorter leg of that 30-60 right triangle, is S over 2 minus N. And therefore, the longer leg, which is N, equals that shorter leg times the square root of 3. So N equals S over 2 minus N times the square root of 3. I distribute the square root of 3 on the right side of the equation, and I get N equals S root 3 over 2 minus N root 3. I multiply both sides by 2, and we have 2n equals S root 3 minus 2n root 3. I need to solve this equation for s, and so I get the term containing s root 3 on one side, and I have, therefore, S root 3 equals 2n plus 2n root 3. On the right side, I factor out the common factor 2n, and then I divide by root 3, and I have S equals 2n times 1 plus root 3 divided by root 3, which is a good answer to the first question. But I am doing as we often do when there's a root sign in the denominator. I'm rationalizing the denominator. I multiply numerator and denominator by root 3, and I get S equals 2n root 3 plus 6n all over 3, or I can factor out the 2 on top and write S equals 2 times n root 3 plus 3n over 3. So that answers the first question, S in terms of n. Now for the second question, finding the ratio area of the squares to the area of the triangle. Well, the area of a square is one side squared. We have two squares, so the area of the squares is 2n squared. The area of a triangle is 1/2 its base times its height. Well, 1/2 the base of this triangle is half of this, which is this without the 2. And the height of the triangle is that times the square root of 3, because we're talking about a 30-60 right triangle here as we imagine this triangle cut in half. So the area of the triangle is 1/2 the base times the height. So our task now is to simplify this fraction. So we have the numerator 2n squared. In this denominator, I factor out the n from both these fractions, which gives n squared, and what's left is root 3 plus 3 squared times root 3 over 3 times 3, which is 9. The n squareds will cancel, and that's as it should be. The answer is going to be a constant with no variables involved, because the area of the squares over the area of the triangle, that ratio, does not depend on how big or how small the figure is. This 9, which is the denominator of the denominator, will move to the numerator and be put alongside the 2. So we have this fraction, 2 times 9 over root 3 times, and we square root 3 plus 3, and we get 12 plus 6 root 3. From this expression in parentheses, 12 plus 6 root 3, I factor out 6, which gives me 6 times 2 plus root 3. That 6 on the bottom and the 2 times 9 on top reduce to a 3 on top. And so I have this fraction, 3 over root 3 times 2 plus root 3. But I'm going to rationalize the denominator. To do that, I multiply numerator and denominator by 2 root 3 minus 3, and I get 6 root 3 minus 9 over 12 minus 9, and 12 minus 9 is 3, so I have 6 root 3 minus 9 over 3. I divide numerator and denominator by 3, and I get what for me is the best answer. The area of the squares over the area of the triangle, that ratio turns out to be 2 root 3 minus 3 over 1. My calculator gives me a decimal approximation, 0.4641, which is a little less than 50%. That means that those two squares occupy a little less than half the area of that triangle, which seems very reasonable. So that's my solution to my triangle and squares math challenge. Thank you for watching this solution video.